Okay, so we will talk about principle of inclusion and exclusion. Okay. Okay, so the principle is like you are trying to include some elements into the set, and then you are trying to exclude some elements into the set. Okay, so that is the principle, and everything has to do with whatever concepts on sets that we have learned in the last class. Okay, last two classes should help you here. All right. So if I take a set, okay, so let's say if I imagine that, let's say this is a set. Okay, so imagine you are stuck in a fancy island, let's say. Okay, so in this island, people eat either pizza or ice cream. Okay, so that's the only thing they eat, let's say. Okay, so if I say A represents the people eating pizza. Okay, so A is the set of people eating pizza. Just an example here. Okay, and one set notation that you need to, let's say, understand is if you take this set A, if you place a line above set, it's called placing a bar. Okay, can you guess what this means? Okay, if A is set of people eating pizza, A bar will be, can you take a guess?
People eating pizza like infinite?
No, 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 no. It is set of people not eating pizza.
Okay.
Okay, so this is set of people not eating pizza. So in this fancy island, in our example, what can we say? A is set of people eating pizza, and then A bar will be set of people eating ice cream. You understand?
Okay, okay.
Okay, so if you have such a simple scenario, okay, if you have such a simple scenario, what again, the rectangle, let's say it is represented by some set S. Okay, so that S is the rectangle. Okay, so the people in that fancy island. Okay. Now, if I divide this into two parts, if I divide this into two parts, so I have one set which is A and the other is A bar. Now, if I'm trying to talk about the number of people, so can I say N of S will give me the number of people living in that island?
Yeah, yes.
Yeah. And then N of A is number of people eating pizza. And then N of A bar will be number of people not
Who are
eating.
not eating pizza. Yeah.
So that means if I add this, I should get this. Right? You understand this? And then here we are saying, suppose if I want to get the number of people not eating pizza, so it is simply obtained by N of S minus N of
A.
Okay. So you understand this?
Yes, sir.
Okay, so now we will try to have one more set. Okay, so we have this rectangle, which is our universal set. And then let's say with A, I'm trying to get another set B. Okay, so let's give examples again here. So if I say A is the set of people, guys, this is just example. So set of people eating pizza, let's say. And then B is a set of people eating, let's say, burger. Okay. Then, now tell me one thing. If I am interested in, okay, if I'm interested in people not eating pizza and not eating burger. Okay, so if I want to get, let's say, I want to find out number of people who are not eating, neither eating pizza nor eating burger. Okay, so number of people eating neither pizza nor burger. Okay, so can I say I can write this as, so if I put a bar, that means I
Yeah.
don't include that, right? So
Yeah,
can I
yes.
say I'll get
A bar and B bar.
so I can say and is like the intersection symbol. Can I say this?
Yeah, yes.
You can say this. Now look at this. If I want to get this number, can I do one thing first? So let's say I'll count, I will include the number of people who are, let's say if I take the universal set. Okay, so if I take the universal set, can I say I'm really looking at these guys represented by this shading? Maybe I'll use different color. Can I say I'm looking at this shading? This is what I want from the diagram. Are you able to see? So any number that is put here will give me a number of people who are not eating pizza, not eating burger. Fine?
Yes, sir.
Okay, so to get that, what I will do is I'll first include. Okay, so I will try to include. I will try to get what here. So what can I do here? I can first get, let's say, number of people in the island, maybe, right? So it will be n of s. So from this, can I say I remove people who are eating pizza? So let's say I'll remove these guys.
Okay.
So I'll first remove these guys. Okay. So I've removed number of people eating pizza. And then, but will I get, I'll have to remove this space also, right? This space to get that blue shaded region. So then what I will do is I will remove these guys also. Okay, number of people eating burger. But do you see there is a problem, right? When I do this, the intersection, whatever people, let's say, with the number of people who are eating both pizza and burger, I've already removed, right? But if I remove the number of people eating burger, that means I have removed this number twice, that intersection number. Do you see that? Guys, are you okay?
Yes, yes.
So then how will I fix this? What should I do to fix it? I will have to add that back, right? So can I say if I
Yes, we
add
should.
that intersection number back, I will be okay? You understand this?
Yes, sir. Yes.
Okay, so this is what is that we are trying to do here. If you look at this, all we are doing is number of people who are eating neither pizza nor burger is the total number of people in that island minus number of people who are eating at least one of this, okay, either pizza or burger. So we know this n of a union b, right, from our last class.
Yes.
Okay, so n of a union b is n of a plus n of b minus n of a intersection b. You understand what is happening here? Okay, So whenever you include something, exclude something, you get that. If you have a minus, that means you are excluding. If you have a plus, you are including. So whatever we are saying is the inclusion exclusion principle. Okay, so if you have more sets, it becomes more interesting. Okay, that is the only thing. You get my point?
Yes, sir. Yes.
Okay, so I think write this down. Okay, Siddharth, what is your doubt?
What?
You said you have a doubt?
No, sir. I told I wrote it down.
Acha, you wrote it down. Okay. So now to keep it more interesting, we'll include one more set. Okay. So we already have pizza, burger. What is the other thing that you like to eat?
Sir, malai tikka.
Malai tikka tea. So let's use malai tikka. So we have pizza, we have burger, and we have the delicious malai tikka. Okay. So again, so we have this universal set is S, and this is A, this is B, and this is C. Okay. Now again, so N of S, S is like all the people, right, in the island.
Yes, sir.
All the people in the island. So A is set of people who eat burger. Sorry, it is pizza, right?
Yeah.
It's okay, but yeah, but we started with pizza, so let's say we'll stick with that. Okay, so pizza looks like an interesting island, right? So
Yes,
people
sir.
who eat burger. Who knows? They might be jogging around the island also, right? So they'll still be
Yeah.
healthy. So malai tikka. Malai tikka.
Sir, you
So
got the spelling
now,
correct.
the spelling correct?
Yeah.
Okay. So now let's say I'm interested in number of people who eat none of these. Okay. So you are interested in people who are not going to eat pizza, burger, or malai tikka. Again, so in terms of the diagram, what am I interested in the I'm interested in this portion, right? So if I put a number in this region, that will give me the number of people who eat none of these, right? Okay, so people who eat none of these, I mean, let's not call junk food. They are healthy. They're good. Okay, they're tasty. Okay.
Yeah.
So,
Especially malai tikka.
yes, especially malai tikka. So if I want, let's say, number of people who eat none of these, okay. So number of people who eat none of these. So how can I get that? It is like n of A intersection B intersection C. Okay, so A intersection, sorry, what I'm saying, A bar intersection, B bar intersection, C bar intersection, right? Okay, so that will be to start with, guys. So if I consider this, let's say this entire region, whatever numbers you get in these parts, okay, so whatever numbers you see in these parts, okay, so that you see here, okay, whatever numbers you see here, can I subtract that number, which is n of A union B union C, right?
Yes, sir.
Okay, so you put whatever numbers here, and if I remove from all the people, I get this, right? Is everyone okay?
Yes, sir.
And we know, right? How can we get this number of A union B union C. How can we get that? Let's see, we can kind of start including, excluding, right? So we can do that. So if you want to get this, number of people who eat at least one of these good stuff, okay? So if they eat, okay, so we can do something like this. So it will be n of A, okay? So if I do n of A, that means I'm including this region, this entire thing. So maybe I'll put a color, okay? So let's put a color. So let's say that is n of A, right? And then I can include B also, n of B. But what is that I'm doing? If I do that, guys, do you see that I'm actually including that intersecting part twice? Do you see that, guys?
Yes.
So that means I'll have to remove it once.
Yeah, yes.
Okay, so let's say I remove it once. Okay, so I remove it once, n of A intersection B. Okay, but let's think about it now. So I have removed it once, so now it everything is fine. But now when I add n of C, what is going to happen? So I have this region, let's say this region. So I'm going to add this intersection again, right? So this was already included, right? I'm adding twice when I add n of C. You understand? So
Yes.
that means I have to remove that. Okay, and then this is also added twice when I add C. So I have to remove them as well. N of B intersection C minus n of C intersection A. But there will still be a problem. Now look at this. Okay, so let's go carefully, see what is happening. Okay, what is happening? When I remove, let's say when I add n of A, what is that I have done? Okay, I have included this A intersection B, right? When I added n of B, I've added that intersection again. So if you pay attention to this, guys, okay, so if you pay attention to these first three terms, okay, so when you add number of people in A, number of people in B, number of people in C, what will you do? If you only add the first three terms, what will you do? You would have added the people eating pizza and burger twice, people eating burger and malai tikka twice, people eating malai tikka and pizza twice. Do you guys understand that? Okay, is
Yes.
everyone okay? Siddharth, are you okay? I mean, just look at the first three terms, right? So now if you remove this, okay, if you remove this, what is happening? Let's look at this. Okay, so you want to remove only once, right? That intersecting part. If you remove this once, that is okay. Okay, so you have counted A intersection B only once. Now, if you remove, let's say this part, what is happening here? Okay, so how do we understand this? Let's look at this. I mean, I will draw here a different picture. Okay. So let's say I'll call this as A intersection B. This is A intersection B. Okay. And then I have this section, let's say. This is what? This is C intersection A. Okay. And then I have this section. Okay. So this section is what? B intersection C. Now carefully see this, guys. When I remove A intersection B, I know if I add the first three terms, what have I done? I have included A intersection B twice, B intersection C twice, and then C intersection A twice. But I was supposed to add how many times? Only once, right? Do you see that? When I add these three terms, you have added that A intersection B twice because it was part of A, it was also part of B. You get that? Everyone is okay?
Yes.
Yes.
But I'm supposed to remove it once, right? If I remove it once, I will be done. So now let us look at this. When you remove it once, what is that you are trying to do? You are removing this. Okay, you are removing, let's say you have removed this. Okay, so you have removed this, and then you are removing this as well. You're removing this as well. Do you see there is a problem that we are getting into? See, understand this, okay? If you have removed this portion, that means this is removed once. Okay, and after that you are removing this. I think that is okay. So you are removing once, that is okay. But now, when you remove this also, what is happening? See, maybe I'll tell you one thing. You try to think of this region as whatever region you are looking at. Can I say there are 4 regions?
Yeah.
Here, can you say there are 4 regions? These are 4 regions, right? And
Yeah,
each of
yes.
these regions should be removed only once, right? You understand? Only once, or guys, how do you do this counting? Okay, I think let's do one thing. Okay, this is a little hard to understand. I understand. Okay, but let's say when I go back to this, let's start looking from the beginning. Okay, so maybe if it helps, let us put numbers. Okay, so let us put numbers. When I take A, let's say if I take this as A, okay, let me put numbers. This is A. What is A? This is A, right, guys? That is A. Let's put that, okay? And then this, I'll put it as B. This as B. Oh, sorry, why am I putting this C? This is C. Okay, so this is C. And
Okay.
here, let's say this is, I'll put AB. Okay, so let's call that AB. I think it is hard to see, right? So let's put this as AB. Okay, and then this I'll call this as BC. You're okay?
Yeah, okay.
BC, and then this is CA, and then जो भी बीच में है ABC. Maybe let us use this idea ABC. You understand?
Yeah.
Now, when I write n of A plus n of B plus n of C, what am I doing? Maybe I'll put it in a different page. Let's say, okay, so if I take n of A, I'll try to separate this out, n of B, and then plus n of C. What is that I'm adding? What numbers am I adding? Let's say I'm adding a number like A, which is counting people who eat only pizza. Okay, and then B, which is counting people who eat only burger, things like that. So when I add n of A, I'm actually adding 4 numbers. Okay, n of A plus people who eat only pizza and burger, and people who eat pizza and malai tikka, and people who eat all of them. ABC.
Yeah.
You see this? This is your n of A. Now, when I do n of B, I will be doing the same thing, right?
Yeah. AB
People who
and
eat burger,
CB.
and then I will be doing these also, right? People who eat burger and pizza, burger and malai tikka, right?
Yeah,
And
yeah.
then you
Yeah,
include
yes.
all of them. So I hope this AB, all these are variables. Okay, you understand?
Yeah, yes.
BC plus ABC. Okay. Now this is over. So this also let us write. Here what will be there? C plus, now you tell me, what do I get from the diagram? I'll show the diagram. So when I add n of C, what am I adding? C plus CA plus B
CA
plus
and
ABC,
BC.
right?
And ABC, yeah.
ABC. But you understand that each of these variables, okay, each of these variable, I mean, I'm treating this as one variable. AB is one variable, okay. AB is just one number. A and B is one number. AC is one number. So do you understand that I'm supposed to add them only once? You understand? I'm supposed to add them only once, right?
Yes, sir.
Yes.
Okay. So now if I remove, let's say if I'm removing intersections, let's say, if I'm removing intersections, A intersection B, and I'm removing what? B intersection C, B intersection C, and I'm removing C intersection A. Okay, so if I'm removing these, what am I removing? Now let's look at this again, the diagram. Okay, so what am I removing? A intersection B is like AB and ABC, right? B intersection C is BC number and then ABC number. Again, I'm repeating, BC is just a number. Okay, ABC is a number. So I will be removing these ones. Let's say this means what? I'm supposed to remove AB plus ABC, right? And I'm removing what? BC plus ABC. Okay, I'm removing what here? CA plus ABC. Do you guys understand this?
Sir.
Yes.
Okay, now when you
So
remove,
removing that thrice.
exactly what is happening. TK, I have AB twice. I understand that. Okay, so I'm removing AB once. That is okay. So let's say I remove AB once, and then BC I'm removing once. That is okay. CA I'm removing once. That is okay. But ABC, what is happening? What you have noticed is very important, Om Prakash. ABC is removed what? Thrice. But do you have it thrice here? Yes, you have it
Yes.
thrice. And then if you remove it, that means did you count ABC? You did not count ABC, right?
No.
Now see what you have counted. You have counted only A, B, C, and then what you have counted? AB plus BC plus CA, right? If you do n of A plus n of B plus n of C minus of n of A intersection B minus n of B intersection C minus n of C intersection C. So that means, can I say that middle portion is left? Do you guys notice that middle portion is left after this?
Okay.
Guys, do you see that? Om Prakash, Harsha, Siddharth.
Yes. Sir.
Yes. Yes.
So that means, how can I fix the situation? I can add it back, right? That middle portion.
Okay.
So that middle portion I can add. I can say n of A intersection B intersection C. Are you guys getting this?
Yes.
Yes,
Sir.
sir.
Okay, so that means now once I have this, okay, once I have this, I can write here. So if I want people who eat none of these foods, I will first count all the people living on that island. I'll subtract people who eat what? People who eat pizza. I'll subtract people who eat. I mean, there is a minus here. So wherever you have plus, that will become minus. And then wherever you have minus, that will become plus. And then this will become plus. minus, oh, what did I do? Plus this plus, and this is n of A intersection B intersection C. Okay, so is everyone okay so far?
Yes, sir.
Okay, so I want you to take note of this. Then we will start talking about how to handle if you have even more. Malab, today, let us not worry more than 3 sides, but let's start thinking even if you go more than 3 sets, how to handle. Okay. Okay, guys. So let us now understand a little more about the notation. Okay. So see, if you have more than 3 sets, naming A, B, C, D, and so on could be difficult. Okay, like we have this virus naming, right? Alpha, beta, gamma, delta, they are doing something. Okay,
Yes.
so instead of naming like that, what they usually do is instead of naming as A, B, C, you can actually call them as A1, B1, C1. Okay, so A1 is the people who eat pizza. B1 is the people who eat burger. C1 is, sorry, A1 is people who eat pizza. A2 is people who eat burger. And then A3 is people who eat malai tikka and so on. Okay, so if you have biryani, A4, ice cream, A5, and so on. Okay, so you can have like that. And one more thing, if you look at the combinatorics books, yeah, you can use n of, but I think the convention is they put a modulus sign. Okay, you will notice that they put this absolute value. It gives you the count. So these are equivalent. So instead of ABC, I'm saying A1, A2, A3. So if I put A1 intersection A2 intersection A3. So that means what am I saying? Instead of A, I have A1, B is A2, and then C is A3. And then instead of writing n of S, you put that absolute value. It is like saying number of people. It is giving the count, that absolute one. So here you will have A. Okay, so this is B. A1, sorry, it will not be B. You have to tell me now. I'll have to write A2 and then A3. Then what do I have? Can you tell me next? A1 intersection A2. And then I have plus A2 intersection A3. Plus I have A3 intersection A1. Then I will have this A1 intersection A2 intersection A3. Okay, now guys, think about this. Can you tell me why there are when you consider the set only once? Okay, so when you consider one of the food items, okay, so pizza, burger, or malai tikka, you have how many terms here? You have 3 terms, right? When you consider 2 food items, okay, when you consider people eating 2 items, how many terms are there? To count those type of people, you have 3 terms, right?
Yes, sir.
Now, when you look at people who eat all of them, how many terms are there? 1 term. Now, can I say that this 3 terms is basically, I have 3 food items. I can eat anyone, right? So to count the number of people who, let's say, number of terms that you are getting here, can I say it is basically 3C1? I'm selecting 1 out of 3, 3C1. So this is also 3C2. Now 3C2 and 3C1, they're equal to 3, that you know by now. Understand? So this is what 3C3 and this is what 3C0. You see the pattern here. Okay, you have 3C0 and then how many terms are there? 3C1 and how many terms are there here? 3C2 and then how many terms are there? 3C3. Now, if you have understood this, suppose I have 4 food items. Let's say, suppose I have 4 food items. Let's say I have A1. I'm trying to find number of people who eat none of those 4 items. Okay. So A1 intersection A2 intersection A3 intersection A4. Forget, let's say, how you write all this, but can you count the number of terms that you get here? So here, how many terms are getting 1 plus 3 plus 3 plus 1? So I'm actually getting how many terms? I'm getting 8 terms. Can you find how many terms we get? Number of terms here. So number of terms is like each of those counts. Either you count all the people or you count people eating, let's say, one of that item, and then counting people who eat two of the items and counting people who eat three of the items and so on. So can you tell me how many terms will be here? I'll give you some time.
10.
Okay, guys. So here in this, first you are counting everybody, right? That is one term. Oh, sorry, I will not use n of notation. Na? So you'll be counting everybody, that is once. Then what are you trying to do? You are subtracting people who eat, let's say, one item each, right? So you are subtracting, let's say, A1. You are subtracting A2. You are subtracting A3. You are subtracting A4. But you recognize that if you subtract this, you have also subtracted people who eat two items. So you are adding that once, right? So you will add. How many terms should you get? See, 4C2 is how much? What is 4C2? Because 2 out of 4 items, right now. So 4C2 kitna aa raha hai? Guys, don't forget calculation. 4C2 is 12. How do we count 4C2? You guys forgot 4C2?
Sir, 1 second.
4C2 is what? 4 factorial by 2 factorial into 2 factorial, right? So you can ignore, let's say, 4 into 3 into 2 factorial by 2 factorial into 2 factorial. You can cancel this out. 4 into 3 is 12. 12 by 2 factorial is 2. So 6, right? You will get 6 terms. So what are those terms? I mean, if you have more than 4, it is very difficult to write all of them. But let's say we can try and write for this. A intersection, what? A2. And then A1 intersection A3. Sorry, we need to add all these. So A1 intersection A4. Then we have A2 intersection A3. Then A2 intersection A4. And then we have, okay, that is bar, plus A3 intersection A4. You see those 6 items? Then we have to subtract what? 3. So those will be again how many terms? 4C3 is what? 4C3 will be 4. So you'll get 4 terms that you need to subtract. So what are those? A1 intersection A2 intersection A3. Okay, so again you'll have to subtract A1 intersection A2 intersection A4. Okay, so I know these are a little hard, right? A2 intersection A3 intersection A4. What is the other thing that I need to subtract? So A2, A4, A1 ho gaya. So then A4, what is the missing one that I need to subtract? Okay, what combination of 3 can I get? Can you check what is that I need to subtract now? So A1, A2, A3 done. A1, A2, A4 is done. A2, A3, A4 is done. So what is that I need to subtract? Can you see? Okay, I'll wait for some time. Can you think? A1, A3, A4, is it subtracted? A1?
I think A4, A3 and A1.
Yes, so that is subtracted. Then after that, what is that we need to do? We need to add all of them intersection. You understand this? So you see a pattern here. Inclusion exclusion principle may you are getting a pattern here. You notice this? You're getting a nice pattern. What is that? If you have, let's say, 4 food groups, let's say 4 food items, you are adding, you are including everybody. You're subtracting people eating one item. So how many subtractions that you will have to make? 4 terms. And then because when you subtract that, you are automatically subtracting the intersecting part. You need to add that. So you will get how many terms? 6 terms. How do you know that you will get 6 terms? You know 4C2 and then so on. Okay. So what I will do, guys, what I will do is this can be understood little differently. Okay, understood little differently. But before we think in that direction, think like that. Okay, so you can actually think in terms of associating some property. Okay, so if a person eats pizza, you can say that he has this property, maybe P1. Okay, maybe you can let's say print the stickers and then put it on his shirt. Maybe. Okay, people who eat burger, you can give them P2 stickers. Okay, people who eat malai tikka, give them P3 stickers. People who eat, I don't know, 4th item could be ice cream, let's say, give them P4 stickers. So you can do that, right? And then you have this property stickers. Okay, we can think in that direction. But before that, what I will do is, let's look at one simple problem which involves these, let's say, A intersection, B intersection, C, whatever. Let's look at one problem.
Done.
Okay, so take this problem as homework, and then we'll discuss in the next class.
Yes, sir.
Okay, chalo. I'll see you guys on Friday then.
Yeah, okay.
Okay, yeah.
Bye, sir.
Bye.
Bye.